So in this problem, we're told that SAT scores have a mean of 1,050 and a standard deviation of 150. Before I answer any follow-up questions about this, I want to fill out the normal curve. You always put your mean in the middle. So 1050 goes in the middle. And then to move to the right, you add the standard deviation, and move to the left, you subtract the standard deviation. So if I add 150, I get 1200 as my next value, and then 1350, and then 1500. If I subtract to go to the left, 1050 minus 150 gives me 900. I subtract again. I get 750, and then I subtract again, and I get 600. So now that we have the values on the curve, we can answer lots of different questions with this scenario. For the first one, it says, what percent of SAT scores are between 900 and 1200? So here's 900, here's 1200. We want this area between my really nice straight lines under the normal curve. According to the empirical rule, values within one standard deviation of the mean make up approximately 68% of the data. So this area right here is approximately 68%. If you are more specific than that, this section right here is 34.1% of the data. This section right here is also 34.1% of the data. So the answer to this question is approximately 68% or 68.2% when you add up these numbers. Depending on the resource that you're using, the numbers may be a little different because of rounding, but just understand that it is approximately 68% or 68.2, whichever one you use. For this next one, it says, what's the probability that an SAT score is above 1200? Asking for the probability is the same thing as asking what percentage of scores are above 1200. So if we find 1200 on our curve, we want everything above 1200. There are a few ways that you can figure this out. I'm going to show you one way that you can do it. Now, this entire curve is 100% of the population. If I cut it in half, that must mean 50% of the population is below the mean and 50% of the population is above the mean. So if I know that this entire space between the mean and then to the right forever is 50%, I can use that to figure out this shaded region. If you know your different percentages, you know that this section that I just put an arrow to is 34.1% of the data. Now again, if we know that half of the curve is 50%, and I know that this portion right here is 34.1%, the shaded region must be 50% minus 34.1%. So you could say that approximately 15.9%, or if you round to 16%, of the SAT scores are above a 1200. The last question is what's the probability or what's the percentage of SAT scores that are less than 750 or greater than 1350? The reason they use the word or is because you can't have both a 750 and a 1350 at the same time. So you find those values. We want less than 750 and we want greater than 1350. So I want that shaded region. Again, there are a few ways you can answer this, but I'm going to use the empirical rule again. According to the empirical rule, this section, 2 standard deviations away from the mean, is 95% of the data. In other words, 95% of SAT scores are between 750 and 1350. I don't want that though. I want this shaded region and I want this shaded region. The entire curve, like I said earlier, is equal to 100% of the data. It's the entire population. So if the portion that I don't want is 95%, that means the portion that I do want must be 5%.